So my name is Chris. I work at Twitter in the VM team, and I live in Hawaii, so I thought I come out with a Hawaiian shirt, and I promised some people yesterday that I would wear my flip-flops, so I'm doing that too. Okay, so Twitter has a VM team. I think everybody knows what Twitter is here, but maybe not everybody knows that we have a VM team. I'm meaning to put up the actual pictures of our people, so we're basically like 3 GC engineers and 1 compiler engineer, that's me. And so this time I'm going to talk about Graal. I hope everybody knows what that is. It's a JIT compiler, a new JIT compiler that can replace C2, and it's written in Java. And Chris Seaton, after my talk, will talk a little more about it, how it works and stuff. So I'm just showing you how we use it and what our advantages are, or what the advantages are that we are seeing. So what's the goal of this talk? There are 2 goals. One goal is I'd like to encourage you, or at least show you, that it works and you can actually use it in production and what the advantages are. And so that you might try it as well, download it, run it on whatever you have, your applications, maybe try it in production, see how it goes. That's one motivation. The other motivation is we want to save money, right? That's what matters. And Twitter is, as you know, a hugely distributed system, right? I mean, we have thousands of services, I don't even know how many microservices, and we have very important ones like the tweet service, read and write tweets, and user service that handles all your user data, and the timeline service, it makes up your timeline and all that stuff, and social graph, who you're following and who's following you, that's the social graph service, right? So these are kind of the important ones, but then there are many, many others, like handling URLs and stuff like this, and images, So we have microservices, and we have many JVMs per service, right? We have thousands of machines running thousands of JVMs, and that in multiple data centers. So if we somehow could save some percent CPU here and there, that amounts to a lot of money. And so this is what we're trying to do. So Twitter in general is doing a lot of open source, and we're using a lot of open source, but we're also doing a lot of open source. There's this link down, the one at the top that kind of doesn't work anymore, but there's this new one, this GitHub.io one. Everything's called .io these days. So in general, Graal is a good fit for us, because it's open source, right? You can get it on GitHub, you download it, and you run with it. So that works for us. And we're also contributing back to Graal, so I get back to that a little bit later. Internally, we have our own JDK. Basically, it's just a clone of the 8 OpenJDK 8U repositories, and so we added a bunch of more things. So obviously, we had to backward JEP 243, which is the Jvm Compiler Interface, so that we can run Graal in 8. JEP 243, for the people who don't know, we included that in JDK 9, so that's why we had to backport it. We have a copy of Graal, which is basically a one-to-one copy from GitHub. We just have an internal one for building purposes. It's just so much easier. Then we have something called Contrail. It's like a JFR re-implementation. That's kind of moot soon because Oracle's open sourcing JFR, but we have that. And then we have a few CMS improvements, but almost all of them, as far as I know, are upstreamed. So they're already in OpenJDK. So why Graal in general? Why are we doing this? Why are we trying this? For those of you who know C2, they know it's very hard to understand. Right? It's very old, it's very complex, it has a lot of interdependencies, everything weaves into each other, and it's kind of hard to change it. And the learning curve is very, very steep. I mean, me personally, when I started working on C2, it took me at least 2 or 3 years to fully understand what's happening, right? I mean, you kind of get an idea what's going on after a while, but it's not, you look at the source for 2 months and you know what's happening. That's not the case with C2. And in the last couple years, there were no major optimizations. So no one was working on new escape analysis. No one was working on making inlining better. The only thing that happened was Intel was coming out with new chips, and then Intel was contributed handwritten assembly code intrinsics for certain string operations and cryptographic stuff and so on. So there was only this, small improvements at the very low level, but there were no major compiler technology advancements. And so my personal view here is that C2 reached its end of life a long time ago. It's just we have to live with it now because there's nothing else to replace it really, besides Graal. And it's, to be honest, it's a good compiler. I mean, it produces very good code. So Graal, on the other hand, is much easier to understand. It has a very modular design. It's like, this is kind of an old screenshot, but it has around 80 packages, and you have architecture-dependent packages and architecture-independent packages. The build system makes sure, this was done before there was Java 9 modules, right? But it's basically imitating that. The build system makes sure you don't have circular dependencies, and architecture-independent packages don't depend on architecture-dependent stuff. You get the idea. So it's well structured. And very important is it has better inlining and escape analysis than C2 does. So Graal does something called partial escape analysis that's better than what C2 does, and just the way inlining works, it works just different than C2's. So this is where we get back to later when we look at graphs. So I started to work for Twitter about a year and a half ago, and so I had this idea, hey, let's try Graal. Let's see how it goes, right? No one has ever used Graal in production before. So the big question was, is it mature enough? Is it production quality? Does it work? Will it crash all the time? So we found a few bugs, but I think I'm listing 4 bugs here as far as I know, and these are basically all the bugs we found. And I think the last bug we kind of found around this time last year, and since then there was nothing new. But let's go into these bugs a little bit. So there was one, it's not really a bug, but in a way it is. You can look it up, Graal core, that's kind of the old repository, but it's still around. So there was a bug with OSRs. I know you guys are pretty hardcore here, so OSR is an odd-stack replacement. It's kind of optimization a VM does. And I was running a service, and it might have been the tweet service actually, and I turned on print compilation to see what's happening, right? And I saw these compiled skip messages flying by, and I thought, okay, what's that? And it says OSR with locks not supported, and the exception looks something like this, right? It's some phase in Graal. That's the nice thing about Graal. If something goes wrong, you actually get a stack trace, and the thing doesn't crash and doesn't go down. It just gives you an exception and carries on. Your application doesn't go down. That's really nice. So it looks like that. And so I discussed this issue with Tom Rodriguez a little bit. And then we realized, well, it's actually not a big issue because we run in tiered mode, C1. You compile first with C1 and then with C2, or in our case, C1 and then Graal. It's not that important, at least for our case it was not, because number one, it was not an important method, it was not a hot method, it was just a method that was lukewarm and it got compiled, but it was not important. And if that skip message happens a bunch of times, it gets flagged and then it will not be compiled in tier 4 anymore. So it will be just compiled with C1 and you run with that. So you still get native code, it's just not as good, but it's still good enough. So we said, all right, but it would still be good to fix it. So it was actually fixed, but the bug was not closed. I think it was someone heard about it and fixed it in Oracle Labs, but the bug was not closed, so it's still open, which is actually good, because once I found out it was fixed, I tried again, and then I saw these no unstacked replacement node guys, and then we looked at that, right? And Tom looked at it a little bit. So we're not talking about the last one. We're talking about the first two ones. And so there is, when you access static fields in static class initializers, you're actually not really allowed to do that, right? Because it's not fully initialized yet. But there's a little piece of logic in C2's parser. There's a link to it that special cases that, right? And it looks like this. That's a little bit of logic. That's the method. Static field OK and sail init. Okay, that already tells us, yeah, it's OK to access it. And the point is, you can do it because you know the class will be initialized, and you can do compiler optimizations on these fields. And it's better to check now than to de-optimize as soon as we execute, right? That's what we want to avoid. When you're compiling this class initializer, and obviously it's hot because otherwise it wouldn't be compiled. But you would de-optimize immediately when you execute it. So we just needed that piece of logic in Graal 2, which Tom did. It's just a one file change with 31 lines of new code. So it was not a big deal, but it was something that was missing. So that fixed that. Then we had this weird error. It's pretty long, some Scala stuff and whatnot. And the problem with that one was that I only saw it with really long-running processes. Like, it took days for this to happen. So it took a couple weeks. And I can't remember how I actually found this out. I was probably just playing around with command line options and adding and removing stuff. But we're using something called Heapster, which is a heap profiling agent. So basically what it does, it instruments code. And since it's profiling allocations, it has to instrument the new bytecode. And that was an issue with something, with a Graal internal, and it's something called snippets. I'm not going to explain exactly what it is, but it's very similar to intrinsics, let's put it this way. And so the problem was, since Graal is written in Java, and snippets are handled specially in the compiler, it tripped over that, because it was annotated through double.value off. Because there's a new in there, right, and that got instrumented and so on. So they were discussing this, and it turned out, it's time to bite the bullet. So they knew this is a rather big change to make this happen probably, but a lot of people out in the world, right, not in labs, out in the world, they use bytecode instrumentation. So we had to fix this one. And it was rather big, right? It's 2,700 new lines of code, 65 files. It's pretty big, but since then, works fine. So then we had, there was, I think this was also the tweet service. That was the one I used the most in the beginning. It was easy to run. In the log file, we saw lots of connection exceptions. And I had no idea where they were coming from. That's one of the issues when you have microservices and something goes wrong. You don't really know, is it you, or is it the other guy, or who is it? So I really did not know how to tackle that problem. And then sometimes it's good to go away and do something else, right? So that's what I did. I was just running test suites for software we were using to see if something would fail, which it did. So I ran the natty 4 test suite, and the buffer tests failed. Okay, that's interesting. So this one's actually a very funny one. So it turned out there's an intrinsic in Graal that does the reverse byte method, right? It just reverses 2 bytes. It was wrong. It didn't work right. And the odd part is This is used thousands of times anywhere, as in other methods and other software, right? And it just worked fine. Just in this particular case, something with the canonicalization didn't work right, so Tom fixed this one. It was basically like, no, not really, but like actually it was just a one-line change, but he had to do something else, and they added a test case and stuff like this. So after that, the connection exceptions were gone, and everything ran fine. Yeah, that was it. So these were the bugs we found, and as I said, since then, there was nothing. So that was it, at least for our code. And we are running a bunch of services now on Graal, so that was that. Contribution, so I'm working on something right now since Java 9 is out now. When I wrote the slides, it wasn't, but it's out now. And it has compact strings. And as I said earlier, the optimizations that were done for C2 were mostly intrinsics, handwritten intrinsics, and that happened for compact strings, unfortunately, too. So they tried to make it work with unsafe, but kind of C2 tripped over that, and so there's a lot of handwritten assembly code to make it run fast if you have compact strings, but they're really intrinsic, so we have to port them to Graal as well. So I started doing that. I started out with the, can't remember which one, compare to, yes, compare to. So that's just a compare to benchmark with Graal before, look at the third row with the 2600, and then at the bottom it's 126, something like this, right? So the bottom numbers are what C2 has. So the intrinsic works fine. I just didn't have time to finish it up. I have to add a test case and some other things. But it's working fine. So we're starting to do these things because if we want to continue running on Graal, we need that. So yeah, that's the only one I've done, and not even finished yet. But let's come to the important part here, numbers. So I mentioned the tweet service a bunch of times. It's a finagle thrift service. You can download the source code here, and it's an extensible RPC system for the JVM. I don't know what it does, but it's very neat. The important point here is it's almost exclusively Scala. So almost all of Twitter services are written in Scala. We have a few that are written in Java, but Scala is our main language. And the test setup that I have is I have an isolated test cluster, because if I started out doing testing and benchmarking in the production cluster, but that doesn't work well, because we run many different services on one machine, and there's a lot of cross-talking going on. And so this never worked. I didn't get good numbers out of it. So I got my own cluster. I have like 6 machines or something. They're all the same hardware, exactly the same setup. And I was using these. I have one dedicated machine per instance or configuration, like C2 or Graal. And then, very important, all of the instances receive the exact same requests at the same time. They're all running at the same time. They receive the exact same request. It's dark traffic. It's read-only traffic, like real production load, but we don't write. So we just consume and read the tweets, and that's what we benchmark. Then the JVM CI version is 0.30. It's probably not that important. And then the Graal version we used was 0.22. I think we are now at 0.29 or 30. I don't know. But not a lot changed since, so it's still pretty up to date. Then by default, we run with tiered C1 Graal, as I mentioned earlier. So you start up, you interpret, you compile with C1, and then once you hit tier 4, we compile with Graal. Graal bootstrapping, so this is the kind of meta-circular issue. If you have a JIT compiler written in Java, when you start up and it starts compiling, it will compile itself, right? So it's not an issue for us because we're not starting up something like an IDE, right, where you sit in front of it and you wait for it to come up. We have thousands of services and we do rolling restarts, so if one instance takes 10 or 20 seconds longer to come up, it really doesn't matter in the big picture. So for us this is not important. And in the default setup, Graal is only compiled by C1. So it doesn't compile itself, it's only compiled by C1, which is much faster, so the overhead is not that bad. And if it would be an issue for you, for example, you could run with JDK9 and do AOT compilation of Graal, and then all this would go away. But since we run on 8, we can't do that. Okay. So all the graphs that I'm showing you are 1 day, 24 hours. One thing to notice, except one graph doesn't have a y-axis, and that's on purpose, because I'm not allowed to tell you. So I'm not allowed to tell you how many requests per second one machine receives. I'm not allowed to tell you how many GCs we do per minute, all that stuff. But I'll have ratio graphs later, and then you'll see the actual improvements. So 24 hours, you see we have blue is C2, orange Graal. Then I threw in JDK9 just to show it's basically the same. And JDK9, because of the AOT solution that I was mentioning, that AOT solution is using Graal as a compiler. So JDK9 has Graal in it. I'll show you that later. It's just the command line flag you turn on and then you run with it. So I threw that in, that you see it's the same performance basically. Okay. So this is, the tweet service runs parallel GC. And this is a moving average over 60 minutes, so it smoothes out a little bit of the scavenge cycles that we're seeing. So as I said earlier, Graal has a better escape analysis and better inlining than C2 does. So what we want to see is less cycles, which we do. That's great. For now, you can't really tell how much it is, right? But then we have JDK9 C2. It's roughly the same. It's slightly better. And then we have Graal with JDK9, which is exactly the same as 8. So this is about 2.7, 2.5, a low load. When the load's higher, we see more improvement. So it's 2.7% less GC cycles, which is great. I mean, it's not super, right? 50% would be great, but you got to do your work, right? So you have to serve the tweet requests, and you have to do some work. You can't get rid of all the allocation. But that's pretty good. So this one is the old gen. It doesn't really matter how big it is, but one thing I noticed when I talked to our service owners and tried to convince them, hey, there's this new compiler, no one's using it in production and it might crash, do you want to try it? One thing not most of them, but some of them came back to me and said, hey, because they're monitoring the metrics really closely, right? They want to make sure that everything runs fine. And a bunch of them came back and say, hey, it's using more old gen, right? You see the bottom line is where after the full collection, and then you see the blue line is lower than the orange one. And it's roughly 40 megabytes. That's what we're seeing across the services. And this is just 40 megabytes, right? If your old gen is 200 megs, it's 40 megabytes. If your old gen is 10 gig, it's 40 megabytes. It's just the state Graal has, right? It's a Java application. It has some state. It has some static field. It caches probably some things. So this is what we're seeing. We're seeing 40 megs. There's also, I don't have a graph for that because we don't keep track of metaspace really in a way that I could show you. But it also uses metaspace. And metaspace is between, I think it was like 10 or 20 or 20 or 30 megs, so in that range. And that's because it's a Java application. You have to load in some classes. You're loading in a bunch of methods, right? They get compiled. You're using up metaspace. But it's not the end of the world, right? If your heap is, I don't know, 8 gig and you're using an additional 100 megs, it's probably fine. At least, again, it's not a problem for us. So this is the important one, right? So we want to reduce the CPU time. This is CPU time over the day. It kind of looks like the scavenge cycle graph. And this is what Graal does. Well, that's already pretty good. Still, you can't tell how much it is, but you can see there's an improvement. Then we have C2. Don't ask me why. In this experiment, it was better than 8. It might have been some, weird profiling, the race of compilation. Sometimes it just inlines differently, and then the code is slightly better or not. But Graal's the same. So, okay. How much is this? So, finally, we have a y-axis, and you can roughly see how much that is. And we're saving 8% of CPU, which is big. I mean, I work in compilers for many, many years. And people who work with compilers, if you can write an optimization in a compiler and you get 1%, you're super happy. If it's 2%, it's like a lottery win, right? But we're seeing 11 here. And that's really big. So this tweet service, it runs 100% in production on Graal today since, I can't remember, probably 4 months, 5 months now. And maybe you should try to tweet right now to see if it actually works, but I don't think anybody noticed tweets disappear or crashing and stuff. So it works just fine, right? As I said, we fixed a few bugs, but since then, it just runs smoothly. And we're using 11% less user CPU time for that. We're also running a bunch of other services on Graal, also 100% on Graal in production, like the user service and the social graph service, and a few smaller ones that are, not that important. And the goal is to move completely to Graal, which is a bigger step. As I said earlier, you have to convince people that this is safe and it will work. If Twitter goes down, a lot of people are unhappy. So you got to make sure that it works fine. But the goal is to convert all of the services to Graal. So we've seen that we saved 2.5% of scavenge cycles. And so the question is the 11% savings that we're seeing, is that kind of related to escape analysis, or what is it really, right? Because as I said, escape analysis is better than C2, so maybe that's it. So I did a quick experiment and turned off escape analysis for both compilers. And it's a different day, because I couldn't run the experiment at the same time, right? So the graph looks like this, but it's basically the same. And I'm only doing C2 and Graal to compare them. So the scavenge cycles, to make sure that we really turned off escape analysis. Yes, we did. Very good. So the flags work. And then CPU time, we're seeing this. It's not as big as it was earlier, but it's still something. And it's 5%. So I ran this experiment once before, and it was actually more than 5. So, it's in that range. But what I'm trying to say is, it's not only escape analysis that brings the improvement here. It's the inlining. The inlining's better. And this works for our services. Works great, right? So, and I still think that there is a lot to gain here. So, I can't tell you how much money we're saving, obviously, but we can somehow make numbers up, right? To just get a feel of how much money you could potentially save. For the people of you in the room who have their own data centers or who use cloud services and pay for it, you know how much you're paying for it, right? So you just calculate it yourself in your head. But for people who don't, we just assume like this artificial company, and we're doing this back of the envelope calculation. So I was looking up some cloud hosting providers on Google, and these popped up, and I copied them, and you see, oh, it's this much per hour, and I don't know, they list it differently. The ones done here, CPU per hour, and so on and so on. So I calculated it for you. It's between 72 and 210 US dollars per year you pay for a CPU core. And so it's actually, that tells you choose your provider wisely, because you can save a lot of money just right there. But that's, I just take the average. It's really just a back of the envelope calculation. It's not that important. But it's like $127 per year per CPU core, roughly like this, right? And then the question is, okay, how many machines, how many cores are we actually talking about here, right? Again, I can't tell you how much we have. But there's a Bloomberg article from 2014, which is already 3 years old, and it says that the big players like Amazon, Google, and I think they list Microsoft in there. They say Amazon over 1.5 million servers globally, and maybe even 2 million. So that's a big number, right? I mean, we are obviously not as big as Amazon or Google, but we have a decent size, so we're not taking that number. It's just to show you the sheer size of data centers these days. And if you can save some CPU there, you can save a lot of money. So again, your company is probably smaller than Google, but let's pick a random number. Let's say you have 10,000 servers, whatever. And then usually each server has like 24 cores, and then 127 times 24 times 10,000 is like you spend $3 million a year just to run these machines. If you could save 11%, that's like $300,000. And that's probably 1-2 software engineers you could hire for that money. I mean, I don't know how much you guys make, but so that's pretty good. And so we tried to, we saw the number, we saw the 11%, and that's great. And we saw that it's not only escape analysis that brings us the win, because that's what, I didn't mention that earlier, that's what the rumor says, right? The rumor says, oh, Scala is allocating all these temporary objects that you don't really need, and so if they get escape analyzed, that's where the win comes from. That's what I initially thought as well, because I heard this rumor, but then I had to verify, and we saw it. No, it's not only escape analysis, inlining is also very important. So the question is, can we maybe squeeze out more, right? And so it turns out, yes, we can. And like C2, Graal has also a number of parameters. You can tweak inlining parameters. And so I sat down one afternoon, right, and was fiddling around manually just to figure out, could I get any more out of it? This should actually be done by a machine, right? You have some auto-tune service, some machine learning, whatever, that's the buzzword. And have a machine do it for you, run different flags and different numbers pass into your VM, and just figure out if it's better or not. So I thought I'd just see if it would work just in theory, and then we can throw a machine at it. So coming back to the original day, that's the same, because I was running the experiment at the same time. So we have this new color coming in here, X pyramid, and again, same number of requests. Then scavenge cycles. Oh, that's nice. It's a little less. It's another 1.5%. That's pretty good. And what about CPU time? Ooh, a little bit more. That's good. Let's see here. Oh yeah, that's something. It's another 2%. That's great, right? So in our calculation, what was that? Like 3 million, and 1% is another $60,000. That's cool for just an afternoon of fiddling around with some flags. And if you would, as I said, if you would use machine learning for that, you could probably squeeze more out of it. So, as I said, Twitter has its own VM team. Not every company can afford its own VM team. So for you and for everybody else, the question, is there official support, is very important. The answer is kinda, right? So as I said, JDK 9 contains Graal because the AOT solution is using it. And you can use it as a JIT compiler with these flags. So since there are experimental options, you have to turn that on, and then you say, okay, I want to enable JVM CI, so you do that, and then you tell the VM, oh, use the JVM CI compiler, and then it replaces C2 with Graal. That's how it works. I tweeted this because people were asking me about this all the time. So I tweeted that. If you go on Twitter, you can find these as well, or pick it out of the slides if you want to give it a shot. So this was in August, late August. There was this innocent-looking review going on the mailing list. It says build Graal regardless AOT build. So Vladimir sent that out. The important thing here is, let me zoom in on that one. We are planning to have Graal as an experimental JIT compiler on Linux in next release. Okay, that's interesting. That happened before the new release cadence was released. So when he wrote that, he meant JDK 10. And now, we all know that's not going to happen. So I'm not exactly sure if that means the release in March or the one in September. But one of these releases will have experimental support. Right now, there's no experimental support whatsoever. There is just AOT, and that's experimental, but not using it as a JIT compiler. But it will come. And that also means that Oracle is going that direction, that they're committing to the project. As well, and some of you might notice a new project called Metropolis. And so John Rose proposed this one, and John and I, we talked about this project for a long time, and we wanted to do it and to use the initial idea was to rewrite the bytecode verifier in Java, and then just AOT compile it and link it into the VM, because it would be so much easier to write the bytecode verifier in Java than in C++. So that was the whole idea, and eventually they came through and proposed this new project. There's this word Java on Java in there. That means basically the meta-circular thing. And it also says, let me see where it says that. Our starting point is earlier proposals for using the Graal compiler and AOT static compilation technology to replace the Hotspot server compiler, which is C2, and possibly other components of Hotspot. So this project directly talks about, okay, we want to get rid of C2 and replace it with Graal. It's still not, supported, but it's going in that direction. And so for us, it's very important that we are kind of ahead of the curve and make sure if something like Graal comes along that we are fine, and then that our stuff runs well on Graal. The thing I said is that most of our services are written in Scala. And that's the main reason why we are seeing these improvements. And I'm thinking about doing another talk like this, where I kind of explain this a little better. But it's the main reason why it works so well with Scala is because of the polymorphism that happens in Scala. It's like with Java, it's very different. And you always, if you want to replace an existing compiler, right? Everybody will look at performance, right? If you run your application or your benchmark, and then you try a new compiler or a different compiler, and that compiler is slower than the original one, why would you bother using it, right? But C2 has been tuned many years, 15 years, to run well with all the Java code that's out there, right? It has a very broad user base, and you get the craziest customer code thrown at C2, and we spend a lot of time optimizing that one, which is also one of the reasons why no one's doing big optimizations in C2 anymore, because it's been optimized to death. It's just you cannot even tweak the inlining because you would break so many people. No one wanted to do that. So this is the main reason why I want to replace C2 with something else. And one obvious candidate is Graal here because it works so well, but it could be anything else, to be honest. We need a new foundation for doing new research and new work and new optimizations, and C2 just isn't that. We need something new. So yes, as Java is unfortunately a whole different story. So if your application is written 100% in Java, and you're downloading Graal and you expect a 10% improvement, probably not. It's just the difference between Java and Scala that doesn't make that happen. But you might see something. So I mean, I ran a bunch of benchmarks and different things, and we see improvements here and there. It's like a 50-50 chance if it's better or not. But as I said, that whole topic, that needs its own talk, and maybe I'll do that the next time. Yeah, I think that was it. I forgot to mention this earlier, so we have our own Twitter VM team hashtag. If you're tweeting about this talk, it would be great if you could add that hashtag and send some love to our people in the US. Yeah, that was it. Thank you very much.
Thank you very much. Christian, questions?
Question about the optimizations.
Yeah.
Have you done measurements on how long does it take for Graal versus C2 to recover in case the optimization happened and you need to recompile a hot method?
So the answer is it's basically the same. There's not really a difference, but the answer is slightly more complicated because, as I said, in the default setup and the default configuration in the tiered setup is you compile Graal only with C1. So just by that, it means that Graal's throughput is not as good as C2's just because you only compiled with C1. You know, C1 doesn't do escape analysis and stuff like that. But if you would compile Graal with Graal itself, then you would have basically the same throughput, and we measured that. So if you compile Graal with a decent compiler and C2, it's basically the same throughput. So if you de-optimize and then you have to recompile, it's pretty much the same.
So I guess the implication is that compile times for an average method are about the same for C2 and Graal, or is Graal slower or is Graal faster to produce this high quality code?
It's roughly the same. And the main reason for this is one thing we're really looking forward to is Project Valhalla for value types, because that would be really useful in a compiler, right? Because your data structures are just bigger than in C or C++. So you're allocating a little more memory and all this, and that takes some time away. But one big difference between C2 and Graal is, and I mentioned this earlier to someone, that C2 has a graph coloring register allocator, and Graal only has a linear scan register allocator, or only, right? But as you saw, it doesn't really matter. And the numbers I remember, I haven't measured this in a long time, but I think the rough number was that 30% of the compilation time in C2 is register allocation. So it takes up a lot of time there, and using linear scan, it's just so much faster, so that's why the throughput is about the same.
Thank you.
Yeah, Chris, so what's the plan for compact strings? That's one question. And second, are there any other features that you hardly depend on, like this?
You mean other features that we would have to port to Graal?
Yeah, that requires some special
support. Right. Well, I mean, if I wouldn't be here doing talks and stuff, I would probably be working on getting this compact string stuff done. So I will finish it up. It's this one compared to intrinsic, and then there are a handful of smaller ones that need to be ported as well, but they're much easier because they're small.
You are doing this.
We're doing it, yeah. Or you can do it if you want. And other things. I think there are a few string intrinsics that haven't been ported yet, but they're not that important. The important ones have been ported, and it's the way they're implemented. Sometimes, I think the crypto intrinsics, they were written as stubs. So the compiler just calls out to the stub, and then the handwritten assembly code does that. We don't have to port these, but the ones that are actually intrinsics, we have to port.
Okay, any questions?
Well, first of all, thanks for your talk. I have a question regarding the gain. When you were talking about the 11% and 5% gain, is that the gain you got only for the compilation or for the whole code running?
Oh, no, it's runtime. So it's when your application's running and doing its work, like in our case, the tweet service, so it's serving tweets, reading and writing tweets, it's using this percentage less CPU. So there's this was running for a couple days, and when I took the snapshot, it was already like 3 days running, so there were no compilations going on anymore.
Okay, and another question about the optimizations. If I got you right, then, well, does it mean that the code that is got by the Graal compiler is more stable and less the optimizations required for this code?
No, not really. I mean, the way C2, the way Graal works, it's very similar to what C2 does. So it does all these uncommon traps and de-optimizations, and it does all that. Maybe what you're talking about is when I talked earlier about the exception being thrown and your system is not going down. Maybe you're talking about this? No?
Probably I missed the beginning of
one thing that I think is really cool about using something like Graal is when I worked at Oracle on C2, most of the time when you get a compiler bug in, it's a bug in the compiler. Like the compiler crashes because you have a null pointer dereference or something like this. Very rarely it was actually miscompiled code, so that the code you have compiled is crashing later. And the good thing about something like Graal is, if you have a null point exception, you get an exception, you catch it and you move on, right? And you just don't compile that method, which is totally fine. So that's one of the advantages of using Graal. It cannot, I always say the compiler is an optional module in the JVM, right? It's an optimization. The JVM, you can't live without a GC. You need a GC. But you could technically live without a JIT compiler. You could run interpreter. It's just slow. And so this optional module, if it can bring down your whole application, that's not good. But if it's written in Java, you catch all your exceptions and you're fine.
Okay, thanks.
Hi, Chris. You told you've played with inlining parameters and so on in Graal, but C2 also has a lot of parameters. The simplest example is max inline level, which is extremely low. The default value is extremely low, and probably C2 can be improved by playing with parameters. Did you try?
That's unfortunately a good question. Yes. No, I did not. And the main reason is because I don't want to. As I said, it might be possible, and it might be a good exercise to verify that. But as I said, it's the inlining heuristic that C2 has been tuned for so many years that if you have you changed it for your applications and it actually was better?
It was not can't tell numbers because they differ for different applications. But, well, there was an improvement.
Okay, yeah. But sometimes it does not improve just because it has been tuned so well. But you're right. I probably should do that and see how much we can gain there.